Hi, it's Miss House. This video will go over section 2.9 marginal analysis. By the word marginal, we mean the change at a specific level of production, sale, cost, revenue, etc. Profit. Anything that can change at a certain level of production, we call that marginal. So when you see the word marginal in a problem, then you know that that means the instantaneous rate of change, which is the derivative. So there are a lot of different elements of business production. So we'll go over each of those elements. The capital letter C will stand for cost. So C of X is the cost function. C of X is the cost to produce X items. So if you're making picnic tables, C of 5 would mean how much does it cost to make 5 picnic tables. C prime of X is the marginal cost, that is the derivative. And that means how costs are changing specifically at X items. So C prime of 5 would mean the cost, how the cost is changing at the level of 5 picnic tables. So it's going to tell you whether the costs are going up or down for the 6th table, because it's how it's changing at 5 which affects 6. C bar of X is the average cost per unit. The bar over the C means average cost. And to find the average cost, you take the cost, that's the total of all the X items, and you divide by the number of items, and you'll have an average cost per item. So C bar prime of X is the marginal average cost. How is the average cost changing at a production level of X units? The next element is revenue. Revenue function is R of X. R of X is the money collected for the sale of X items. You have to sell something in order to take in the money. That's called your revenue. R prime of X is the marginal revenue. So that's how is the revenue changing at the sale of X items. Now, along with revenue, you'll sometimes see D of X, and the D stands for demand. Now, demand is always, think about this, it's always based on the price of something. If something is priced too high, the demand is going to be limited. But if something is priced low, your demand is going to be really high. And if something is priced just right, well, you're still going to be able to sell that item. So D of X and price are interchangeable. We say P equals D of X. Now, notice that this P is a lowercase p, because there's another P that we're about to talk about. So this is a small p. Now, here's how revenue and price are related. The revenue you take in will be the price of the items times the quantity that you sell. So P times X, or D of X times X, because P and D of X are interchangeable. The next element is profit, and that's the whole point of business. We're not talking about nonprofits. We're talking about businesses that are in the business to make money. That's your whole goal right there, is your profit. And note, this is a capital P. Lowercase p is price, uppercase P is profit. P of X is the profit function. P prime of X is the marginal profit. That is, how is the profit changing at X items? Now, profit is your revenue that you bring in minus your expenditures or your cost. So you can bring in $1 million, but if it costs you $1.5 million to make it, you're not going to make a profit. So your revenue minus your costs is your profit. And so written in formula form, that's P of X, that's profit of X, is the revenue X, R of X, minus the cost of X, C of X. So let's work a few problems related to these definitions. Number 1, the cost of producing X items, or X picture frames, is given by C of X equals 800 plus 1.6X. Determine the average cost function. So average cost, C bar of X, is your C of X, 800 plus 1.6X, divided by X. And we're going to want to go ahead and split this apart. 800 over X plus 1.6X over X. And when simplified, that's 800 over X plus 1.6. Now, there will come a time when we can just leave it all over X. But right now, we don't know how to deal with a fraction to do a derivative. But we do know how to do the derivative of this C of X format. So divide each term by X. So you could just go directly to this step first. C bar of X, and this little bar did not print well. C bar of X is each element of the cost divided by X. So our answer is 800 over X plus 1.6. So a vendor charges $43 for a jacket. What is the demand function? Well, D of X is equal to P is equal to 43. Because our right now at least, our price is a constant. It doesn't say they're going to change the price. It says that the price is 43. So D of X is 43. Number 3, a vendor charges $39 for a shirt. What is the revenue function? Now remember, your revenue function, R of X, is your D of X, or your P, times X. Okay, price times quantity. So in this case, it's the price of 39 times the number of units sold, 39X. Number 4, a supply company charges for 55-liter drums using the demand function. P of X is 21.5 minus 3.8X. Well, in this case, our price is changing based on the number of units, because they give us P of X is 21.5 minus 3.8X. And our revenue of X is the price at X times the number of units. So for us, it's going to be 21.5X minus 3.8X squared, because you have to take both of the elements of the price function and multiply them by X. Number 5, the weekly cost of producing X shirts is given by the function C of X is 2,700 plus 30X plus 0.15X squared. So C of X is 2,700, that's a constant, plus 30X plus 0.15X squared. And we're asked to find the marginal average cost function. So what we have to do is we have to first find the average cost. Let's do that. First, let's find the average cost function. So look, 2,700 over x plus 30 over x plus 0.15 x squared over x. I'm going to write these so that I can take my derivative using the power rule. So we don't do anything with division. Oh, let's see, 30x over x. Pay attention to that x here and an x here. That means this is just going to be plus 30 because those x's will reduce out. And this is going to be 0.15x because when you have x squared over x, that's going to leave a single x in your numerator. Now, the marginal average cost is the derivative of this. So remember, when you have a power, it's coefficient times the power and subtract 1 from the power. The derivative of a constant is 0, and the derivative when it's the first power is just the coefficient. So our answer is negative 2,700 x to the negative 2 plus 0.15. And that's a completely acceptable answer, but if you reduce it by moving that to the denominator, making it a positive exponent, you can get a bonus point. So make sure you think about that. You don't have to, and certainly you don't have to in Hawks, but on a test, that's going to get you a bonus point because that's really a better format. So we'll take a quick break and we'll come back and do the next 5 problems.